Welcome everyone to the Cybersecurity Magazine podcast. I'm Philippa Jefferies and I'm here with Hans Christian Rudolph, also from CSM, and Alper Yegin, VP of Advanced Technology Development at Actility and Vice Chairman of the LoRa Alliance. Today we're discussing LoRaWAN, what it is, the role it plays in IoT, and of course security. So welcome everyone. Alper, would you like to perhaps kick off by explaining a little bit about what LoRa and LoRaWAN is and kind of the role it plays in the IoT ecosystem?
Sure, thank you, Philippa and Hans. It's great to be here. So let me briefly describe what LoRaWAN is. LoRaWAN is a wireless data communication technology, and it is specifically designed, implemented, and deployed to serve better operated IoT devices for communicating over a long distance. Mm-hmm. So the mostly sensor devices that need to operate in the field for 10 years or more, these are the kind of devices that we have this technology for. When I say sensors, actually, we also support actuators, but majority of the IoT devices are the sensors. And these devices, when they need to communicate with the network over several kilometers, like 10, 20 kilometers, or even more, that's where the LoRaWAN comes into the picture. So in a way, you can think of it like a Bluetooth, low energy, that works for 10, 20 kilometers range, and that can also penetrate through the walls. And another significant feature of LoRaWAN is it's using sub-gigahertz ISM band. For example, 868 megahertz in Europe and 915 megahertz in US. And because it's an unlicensed band, it allows both public networks and also private network deployments. And as such, it also creates a very open ecosystem for this technology to be used by anyone who needs to connect sensors to the network and to the internet.
Okay, great. So saying it's something used for longer range and also it's unlicensed, so it's open for everybody. What kind of use cases and applications do you think this is particularly relevant for?
Sure. Yeah, I think it's easier to describe what kind of applications that do not fit LoRaWAN.
Okay.
Let me start with that, and then I'll give you some concrete examples of where we're using LoRaWAN in the world today. So any application that requires massive amounts of data to be pushed, like megabytes, gigabytes of data, or any application that needs real-time communication, such as carrying out remote surgery or remote control of a drone or audio streaming, these are the technologies that do not fit LoRaWAN, because LoRaWAN being used in the unlicensed ISM band, there's traffic constraints. And if you look at the overall IoT market, the kind of applications I just touched upon, they constitute around like 3 to 5% of the IoT use cases. The rest, the 95% of the IoT use cases, where we call them the so-called massive IoT, these are the cases where the device needs to send like tens of frames and less than a kilobyte of traffic during a day. And that's where LoRaWAN has been used. So to give you some concrete examples, smart metering like gas meters, water meters, where these meters are in very harsh RF conditions, like inside the buildings, in the basement, maybe sometimes behind metal closets. Now, the high sensitivity of LoRaWAN is very instrumental for providing connectivity to such devices, and also being low power, because once such meters are installed, they are expected to be there for another 10 to 15 years. So for these two essential features of LoRaWAN, the gas meters and water meters are where we see massive amounts of devices coming on board LoRaWAN networks. And also, especially with the gas meters, we not only do the sensing, reading the usage, but we also have the capability to remote control them. For example, in case of an earthquake, using the LoRaWAN multicast technology, we're able to shut off all the valves all at once using 1 or 2 messages. So that also happens to be an essential feature that the gas metering market needed. And then we can talk about smart cities, like sensors that are scattered throughout the city in dense urban, suburban settings, to provide monitoring of air quality, monitoring the noise level, monitoring the manhole covers against theft and unauthorized access, street lights, and so on and so forth. So smart city is also another use case. And tracking, LoRaWAN also has significant adoption on the tracking, whether it is tracking a machinery at a construction site, or personnel in a building, or skiers in the mountains, or pets at home in the neighborhood, or wildlife in the parks. We see LoRaWAN enabled trackers being deployed. And smart buildings for monitoring room occupancy, air quality, security. And in the industry, the predictive maintenance has a lot of traction. Sensors running AI on the device, and just to notify the events over LoRaWAN connectivity, we see those being deployed as well. And obviously agriculture, where in the field where there's really no other alternative connectivity, placing a low-cost LoRaWAN gateway to provide kilometers of coverage at a very low cost is what the agriculture market has been enjoying. So as you see, it's all across the board, except for like video streaming, or watching YouTube videos, things like that, or having super real-time communication needs. That's where LoRaWAN has been adopted already.
Okay, and just out of interest, like, how widely used is LoRaWAN currently?
Well, today, actually, yeah. So I mean, there are two types of customers of LoRaWAN. One is the public operators. The other one is the private enterprise users. So the public operators are the ones that are typically cellular operators as well, who would like to provide nationwide coverage. So we have nearly 180 public networks all around the world that has been deploying LoRaWAN. For example, in France, there are two public operators, Orange and Obgenius, or Bouygues Telecom. They have nationwide coverage for the past 3-4 years. So if you were to travel to France, you can walk into an Orange store and then buy a LoRaWAN enabled tracker and put it in your backpack, and then know the whereabouts of your backpack across the whole country. The same is true in Switzerland by Swisscom, in Netherlands by KPN, in Finland by Digita. So they have nationwide networks. And then, so we see such networks also being built in North America, in Asia, in APAC region, all around the world. And then there are the private networks where, instead of relying on a public infrastructure, the enterprise, say it's a car manufacturer or a hospital or a university campus, they can build their own private network. It's just like building your own Wi-Fi network for your own use. And there are like countless many of those, again, scattered across the globe. So it's pretty well adapted, but the IoT market has a huge room to grow, and we are at the forefront of providing connectivity to the massive IoT use cases.
Okay, that sounds very interesting, and quite keen to hear more about these different use cases. You just mentioned the IoT market being still in the early stages of development. Obviously, there's a huge headroom left. It also seems that some of the big users of IoT, where you would think they could draw a big benefit out of this technology, are sometimes a little bit hesitant to go or to commit to a certain technology. So there's, as we know, LoRaWAN, there's 5G, which in parts maybe fills or addresses similar issues. What are competing technologies to LoRaWAN that somehow play in the same ecosystem? Sure.
So addressing the massive IoT field, there are actually a number of somewhat niche technologies. But among them, well, not among the niche technologies, but among all the technologies, one that is worth mentioning is Narrowband IoT, which comes from 3GPP, and it is an evolution of LTE. Now, Narrowband IoT also plays into the massive IoT market. And now, the comparison between Narrowband IoT and LoRaWAN is, the story is similar to what happened back in the year 2000 when 3G and Wi-Fi were contending for the same mobile broadband market. Some people said 3G will win, nobody would use Wi-Fi. Some other people said the whole country would be covered under Wi-Fi. And as we move forward, like 20 years later, what we see is 3G and Wi-Fi are coexisting. Well, actually, it's 3G, 4G, and 5G, the three cellular broadband's evolution, and Wi-Fi are coexisting. There are places that they have overlapped use cases, and there are use cases you would only use 4G or 5G, and use case where you would only use Wi-Fi. So we see the similar trend between Narrowband IoT and LoRaWAN. There are use cases that overlap, but then there are several use cases that only LoRaWAN can support, or it'll only make sense to do with LoRaWAN, and some use cases where Narrowband IoT would be ideal. The strength of Narrowband IoT is the real-time communication and higher throughput. So with the Narrowband IoT, you can support up to 250 kilobits per second. With LoRaWAN, it is limited up to 50 kilobits per second. So for those higher end applications that needs more throughput and real-time communication, one can use Narrowband IoT. But for the rest of the massive IoT, LoRaWAN is a much better fit. And if we were to compare the Narrowband IoT with LoRaWAN, the areas that LoRaWAN stands out are as follows. The low power consumption. Typically, LoRaWAN consumes 1/5 of energy that is needed for powering a Narrowband IoT device. And the long range. Now, even though I said the range of LoRaWAN is like 10, 20 kilometers, when it finds line of sight, the range can go all the way up to 500 to 600 kilometers. And you wouldn't find this kind of line of sight on the ground, but you would find that when you're facing the sky, right? That's why you see there are satellite operators who have placed LoRaWAN gateways on the low Earth orbiting satellites, and the sensors on the ground directly communicate with the satellites using LoRaWAN. And that's where we see the ranges like 500 to 600 kilometers. And then again, another comparison point is the cost. The LoRaWAN infrastructure is much lower cost compared to Narrowband IoT. Today in the market, you can buy a LoRaWAN gateway, which is equivalent to a base station for indoor use as low as like $90 or $80. So again, this technology is specifically designed for massive IoT, which requires a very low cost infrastructure to serve billions of devices. And because that has been built into the design from the get-go, we've been able to deliver that promise all along. And then the last difference is the collaborative nature of LoRaWAN. Well, Narrowband IoT requires license operation, so you need to have a license to operate Narrowband IoT network in a given country. And typically you would have like maybe 3 or 4 such operators. If you were to if you wanted to have your own Narrowband IoT network, you cannot build that unless you're one of those 3 operators. Now with the LoRaWAN, any one of us like in this room or anyone on the street can go and buy a LoRaWAN gateway from the electronic store and plug that into his home or office or even outside and provide coverage for himself, herself, and also the rest of the users. And then that network can be set up to have a roaming with the other such community networks and even the enterprise private networks and the public networks. And we have been already building such roaming relationships among the networks. And collaboratively, all the gateways placed in the field by multiple distinct networks can be jointly serving the devices in the field, which is again not possible with the Narrowband IoT because those few operators in a given country, they would not roam with each other. They would not roam with my gateway or your gateway. So yeah, these are the essential differences between Narrowband IoT and LoRaWAN. But like I said before, moving forward, what we'll see is these technologies will coexist. And we're already seeing operators deploying both. And there'll be sensors using one or the other or both, actually, moving forward.
Okay, so you mentioned a couple of things that apparently LoRaWAN addresses that also exist in, if we look at 3G, 4G, 5G networks. Just to stay at the topic of the technology for a second, you mentioned roaming, if that would be an option. I would imagine basic mobility is there as well in LoRaWAN. Say I have a network of 3 gateways, I can just move around from one to another, right?
Exactly. So, roaming is the ability to integrate multiple distinct networks. But even within a single network, whether it's your home network or the network in your campus or it's a nationwide network, yes, you can move around. So we have all this like these tracker devices, right? And their main purpose is to identify the location using GPS, Bluetooth, and Wi-Fi, and then communicate that location information or any metadata to the network using LoRaWAN. And they do move around. They change their location from one place to the other. So they move from the coverage of one LoRaWAN gateway to the other, and they can repeat that across the nation under a single network. So that is already supported. And then they can cross the border into another country and another network's coverage. And when we have a roaming agreement between the operators, we can still continue to reach that tracker as it goes across countries and across the continents, actually.
Okay, so we talked about kind of how LoRaWAN can be used, kind of the benefits that it brings. You've kind of mentioned this a little bit with kind of the limits sometimes of its application, but what are kind of the main challenges or barriers when you're using LoRaWAN?
Yeah, today actually the adoption speed of LoRaWAN is limited by the overall IoT adoption rate. Well, you know, people have been talking about like billions of devices by year 2018, 19, 20, so on and so forth, and we're still trying to get there. And LoRaWAN is just the reason IoT is taking so much time to pick up and to see that elbow, the reflection point, is it's not an easy task. It involves multiple components being integrated. It's not just one technology. There's this sensing technology, there's the end device, there's the application on it, there's the connectivity, there's the network, there's the application integration, and integrating that into the business process and training people, having support of the network, supporting device and all that. And even though we're talking about billions of devices, the market is also very fragmented. Once you do this integration for one use case, then you end up having to do maybe 10 to 19%, 90% of that again for the next adjacent market, right? Say, even for tracking, right? Tracking pet is different than tracking a wild animal, than tracking humans, than tracking vehicles in a construction site. And yet we're still in the tracking vertical. If you jump to metering, to agriculture, to others, a lot of things move around, right? So there's heavy amount of integration to make it work. And that's what's appearing as a speed barrier for the overall IoT. And the LoRaWAN adoption is basically limited by the speed the IoT market is evolving. So otherwise, we are pretty at the forefront of the connectivity for the massive IoT, and we are moving as fast as the overall IoT market is moving.
Okay. Now, of course, at Cybersecurity Magazine, we are particularly interested in some of the security properties. And maybe to start at the very, very high level, could you explain what kind of security threats the LoRaWAN specification addresses? So I would imagine you're obviously looking at the air interface. When you're talking about roaming, there's also communication between networks. So what kind of issues does LoRaWAN consider and try to mitigate there?
Sure. So, well, because we're using a wireless communication technology, the type of threats that we've been dealing is exactly the same as what 3G, 4G, 5G, and Wi-Fi have been dealing with. We cannot rely on physical security. Everything's up in the air. As such, we need to deal with unauthorized access to network, eavesdropping, and spoofing traffic kind of attacks. And the threats are usual, and obviously the solution is same as what we have been using for the past 40 years, right? Which is using strong cryptography. So we are using AES-128. It's the same strength as other wireless communication technologies like Wi-Fi, 4G, and 5G. And we have all the bells and whistles one needs to have for a proper, fully secure end-to-end architecture, such as mutual endpoint authentication, data origin authentication, replay protection, integrity protection, and confidentiality. And when designing LoRaWAN specifications, we have taken security into account from the get-go, unlike how things happened in the past decades, like a patch on. So from the very beginning, we built the security into the solution and made sure it is not optional. And we have used all the experience that we had from our previous engagements with 3G, 4G, 5G, Wi-Fi, and other standards organizations. So you can see the state-of-art security being built into the LoRaWAN architecture and the protocols, and expect to see the same in the products and deployments as well.
I would be particularly interested in the authentication. You mentioned authentication there. How do you manage subscriptions or user profiles, say, in LoRaWAN deployments?
Yeah, so we use symmetric cryptography, and for that, the end device gets identified by a globally unique ID. It's a 64-bit identifier driven from IEEE OUI. And associated with that, there's this 128-bit AES-128 key that is provisioned on the end device. Now, depending on the class of the device, that key might be in the software, or it might even be in a dedicated piece of hardware we call secure element, which is equivalent to a SIM card, but it is not removable. And those credentials get into the device at the manufacturing time. And on the network side, we have the equivalent, we call that joint server, which is a centralized authentication and key management server that has the same set of ID and the root key. And we have a handshake to perform mutual authentication, and we generate session keys to provide data origin authentication, replay protection, integrity protection at the data communication layer after this initial mutual endpoint authentication. I don't know if I answered your question, Hans. I might have lost track once I started talking. So did I, or do you have any further question on this?
I think that answers my question. Yeah. So there's this unique ID stored in a secure element, which is similar to a SIM card, but not quite. Okay, got it. So you mentioned that security best practices are baked into the standards as much as possible, non-optional, which is great to hear. Still, for people who want to use and also deploy LoRaWAN devices and networks, are there any best practices one should be aware of?
Yes, we do actually. So in our ecosystem, we have different kind of players like device makers, gateway makers, network infra makers, operators, enterprise, so on and so forth. Among them, we believe the device makers need the most guidance, because usually they deal with multiple connectivity technologies, and once they find an open source implementation of LoRaWAN, they don't really go back and read the specifications, right? Where we have numerous guidance on, say, how to generate identifiers, how to generate and use cryptographic keys, what kind of security context needs to be made, and so on and so forth. So knowing that they wouldn't read the standard spec, we have generated a technical recommendation that touches upon the essential elements. Like, for example, do not randomly generate a device ID, because we need to have global uniqueness, for which you need to be using an IEEE OUI block, right? Or the root keys. Make sure every device gets a randomly generated root key. Do not use the same root key on multiple devices. Things like that, which might sound very obvious to us here, but to a device maker that needs to deal with like dozen other things, they can easily miss that. And for that, we have extracted all these essential elements, which not only include the security ones, but also other operational elements out of our standard specification, and put them in a technical recommendation and publish them. And the place to find that document and other documents from LoRa Alliance is by going to LoRa-alliance.com, and the documents are under the resource hub. So that's what I would highly recommend for device makers to go download and follow if they are not reading the standard interop specs.
And what about the users themselves when using LoRaWAN? It's like the best practice they can use to make it as secure as possible, on top of what you're building into the system itself.
Sorry, Philippa, I missed the first part. Can you repeat again?
The users themselves. So when they're using LoRaWAN, which they purchased and using the network. What can they be doing to make it as secure as possible on top of what you build into it at the beginning?
Well, I mean, for the ultimate end users, actually, they would not really have to worry about any of this, because the way we manage the way we provision the security keys on the end devices, and then the way they get used, these are all built into the protocol and implementations. So they wouldn't really have to deal with like entering keys or like leaking, etc. So from end user point of view, well, the only thing they should care is, depending on the use case, they may have to make a decision between whether they will have a device that has hardware level protection or not. For example, if I'm just running a temperature sensor, I may not care about that temperature sensor being physically tempered and getting hacked, right? But if I'm running, say, a water meter or gas meter as a utility, now that would be a major concern for me, because people would be motivated to hack into these devices to lower their bills, right? So for that latter type of user, like a utility, they would care about using secure elements in their devices to make sure the keys are stored in the secure element, and those are tamper-proof. No one can extract the keys. No one can interfere with the way keys are used or the session keys are generated, so on and so forth. So yes, the end user will have to care about that, but once they make that choice, the rest of the system would be secured by the protocol design we have assured in the Alliance, and by the proper vendors building proper platforms for them.
Okay, and is that something that from the beginning was very important, like making sure that the security was built into it, so the end users aren't having to be concerned or do extra upon that to make it secure?
Right.
Okay, fantastic. Hans, do you have any more questions kind of upon the security aspects of this?
I think that gives us a good overview. Maybe if we look a little bit beyond what is, or beyond the current state of LoRaWAN, let's put it that way. I would imagine, similar to technologies such as Wi-Fi or 4G, 5G, it's not a one-time effort and now we have a specification and that's it, but it's also evolving and further improving. You mentioned the LoRa Alliance, of course, who is in charge of that. That suggests there are multiple stakeholders involved there. So who are the people defining LoRaWAN?
Sure, yeah. So like you said, LoRa Alliance is at the center of this whole ecosystem. And today we have nearly 400 company members in the LoRa Alliance, spanning across tier 1 operators, enterprises, device makers, infrastructure vendors, cloud providers, so on and so forth. And they have been contributing their security expertise into the security working group under the technical committee. So yes, nothing is static. The architecture and the technology is evolving, and we keep adding new features. So it is in this technical committee, and regarding security, this specifically security working group, where we have all this ongoing work. We are constantly assessing new threats, looking at new use cases, and evolving our architecture and protocols to make them future-proof. That's where the activity is happening.
Okay, and tell us a little bit about kind of what enhancements you have planned for the next few years or so. Like, what is the future, do you think, of LoRaWAN?
Yeah, so like I said, we are pushing the envelope with the IoT, and we're pretty proud to have brought this technology to IoT, because that's what's accelerating the massive IoT deployments.
Sure.
And as one of the philosophy we follow is to work hand in hand with the market. So we try not to over-engineer our protocols and architecture, and we closely follow the needs of the market and react to it in an agile way. As such, we always have a number of work items that we're working on. There's several trains moving at the same time. And I can give you a few examples of what we're working on these days. One is multimodal devices. So coming back to the ISM, use of sub-gig ISM, the channels, the frequencies used for for that ISM band differs across different regions of the world. For example, in Europe, it's 868. In US, it's 950 megahertz. So with the multiple devices, we're looking at the type of trackers that would move from, say, Europe to US, from US to Japan, to China, to Indonesia, right? So in order to support such a device, we're working on a very lightweight mechanism for detecting the location and switching the channel plan. So we are getting a lot of requests for that. Now that people have been heavily deploying trackers, they are hitting this boundary, and we are in the TC building this feature. Another feature.
And what are the challenges for that? Especially, is it kind of like a location thing?
Even in this particular subject, like this multimode.
Yeah.
The challenge is to detect. The challenge is for this device, it needs to detect its region before making the first emission, right?
Okay.
It cannot just probe the network, because if it probes the network using a frequency that is in violation with the local regulation, even if that probing is to detect its whereabouts, it will be in a violation. So the challenge is to make sure it doesn't violate the local regulation when trying to detect its location, so that it can use the right channel plan from the beginning. Yeah, so that's a technical challenge. Yeah. And another item we're working on is supporting IPv6 over LoRaWAN. So that might sound a little odd, because you might wonder, oh, so isn't IP already supported? Well, it is not, right? So just like what Bluetooth, Zigbee, and Z-Wave did, most of our deployments today are not using the IP layer. The reason is the IP headers are such an overhead, like carrying 20 bytes of IPv4 or 40 bytes of IPv6 header just for the sake of transporting a payload. It's an overkill, and for that, our architecture does not use IPv6 by default. But then there's a huge IP-based ecosystem that we'd like to plug in. For that, we have worked with IETF. There's this IETF LPWAN, Low Power Wide Area Networking Working Group, that has developed a super compressed way of transporting IP over constrained links like Narrowband IoT, like LoRaWAN. And in collaboration with IETF, LoRa Alliance members have contributed to the development of an RFC that describes how to use IPv6 over LoRaWAN. Now we are taking that RFC into the technical committee and building around that to provide a full end-to-end system. So that's the other development I can mention. And one last thing to mention is we are opening up new standard interfaces to grow our interoperability surface. So two such interfaces. One is between the LoRaWAN gateway and the LoRaWAN network server. That interface has been proprietary, and now we have ongoing work to standardize that. And another one between the network server and the application server. And with these two additions, we'll have full interoperability across the whole ecosystem, which will accelerate the build-up of the ecosystem, and also bring more vendors and accelerate the deployments as well.
Okay, fantastic. I'm afraid I'm going to have to end it there. We've kind of come to the end of our time, but thank you so much, Alper, for joining us and telling us all about LoRaWAN and the security there.
Thank you very much, Philippa and Hans. It was I really enjoyed conversating with you. Thank you.
Thank you, Alper.